In this lesson, we will talk about petroleum fundamentals. Petroleum is a complex mixture of organic liquids called crude oil and natural gas, which occurs naturally in the ground and was formed millions and millions of years ago. Crude oil and natural gas are of little use in their raw state. Their value lies in what is created from them. And these could include the fuels, the lubricating oils, the waxes, asphalt, petrochemicals, and pipeline quality natural gas. How is crude oil formed? How is oil formed? Since petroleum is important to us, it is important to find out how oil is formed. Oil is formed from the remains of animals and plants that lived millions of years ago in a marine environment before the dinosaurs. When we say marine environment, we're referring to technically as water environment. Over the years, the remains were covered by layers of mud. Heat and pressure from these layers helped the remains turn into what we would today call crude oil. The word petroleum is actually derived from rock oil or oil from the earth. This is a simple analysis of the formation of petroleum, of the formation of oil. So you can see this is a water environment. You can see tiny sea plants and animals that died and were buried on the ocean floor. Over time, they were covered by layers of silt and sand. Over several millions of years, the remains were buried deeper and deeper, and then the deeper they go, the more they experience the effect of heat on them. The enormous heat and the pressure eventually turned them into oil and gas. And that is why today, when we drill down through layers of sand, silt, and rock to reach rock formations that contain oil and gas deposits, we can easily get these deposits, bring them out, and use them for whatever it is we want to use them for. The next question we want to answer is, where do we get oil from? As we know it, not all the countries in the world produce oil. There are countries that are blessed with these kind of resources. So let us quickly look at a few countries where we get oil in large quantities. The world top 5 crude oil producing countries are Saudi Arabia, Russia, United States of America, Iran, and China. These are leading crude oil producing countries. Maybe there are 1 or 2 countries in Africa like Nigeria and other African countries where we can actually find crude oil in addition to these 5. Let us quickly look at petroleum hydrocarbon structures. We have 3 petroleum hydrocarbon structures: the paraffins, the hydrocarbons, and the naphthenes. Now that we know how oil is formed and we know where we can get oil from, and we also have an idea of the structure of petroleum hydrocarbon, we will now talk about the refining of oil refining production process. What are the processes involved when it comes to the refining of oil? The first process is desalting and dewatering. And secondly, we have the distillation process. And then thirdly, we have the reforming process. Fourth, we have the cracking process. Number 5, we have the alkylation process. Number 6, we have the isomerization process. Then we have the polymerization process. And lastly, we have the hydrotreating process. We're going to look at these processes one after the other and try to gain some knowledge, some important information and details about them. Desalting and dewatering. Crude oil is recovered from the reservoir mixed with a variety of substances. Those substances include gas, water, and dirt, which can be referred to as minerals. Desalting is a water washing operation performed at the production field and at the refinery site for additional crude oil cleanup. If the petroleum from the separators contains water and dirt, Water washing can remove much of the water-soluble minerals and entrained solids. If these crude oil contaminants are not removed, they can cause operating problems during refinery processing, such as equipment plugging and corrosion, as well as catalyst deactivation. A brief summary of what desalting and dewatering process looks like. And it is important that you're able to define some of these important concepts and you are able to apply their explanations where necessary. Then we'll talk about distillation. The first and the most fundamental step in refining process is distillation, which is often referred to as the primary refining process. This process is usually after the crude oil has been cleaned and any remnants of brine has been removed. Distillation involves the separation of the different hydrocarbon compounds that occur naturally in a crude oil into a number of different fractions. A fraction is often referred to as a cut, and we are going to look at those fractions one after the other as we go on. In the atmospheric distillation process, heated crude oil is separated in the distillation column into streams that are then purified, transformed, adapted, and treated in a number of subsequent refining processes into products for the refinery's market. So when we say distillation column, we are referring to distillation tower, fractioning tower, and the atmospheric pipe still. The lighter, more volatile products separate out higher up the column, whereas the heavier, less volatile products settle out towards the bottom of the distillation column. In the last lesson we had, I showed us some of these lighter materials and the heavier materials, and I showed us exactly, how they appear in the column. We're going to quickly revise it here before we move on. The fractions produced in this manner are known as straight-run fractions, ranging from gas, gasoline, naphtha, to kerosene, gas oils, and light diesel, and then to lubricating oil and residue. Okay, the gas, gasoline, naphtha, down to kerosene, gas oils, and light diesel are separated into the atmospheric tower, while the lubricating oil and residue are separated into the vacuum tower. The feed to a distillation tower is heated by flow through pipes arranged within a large furnace. The heating unit is known as pipe still heater or pipe still furnace, and the heating unit and the fractional distillation tower make up the essential parts of a distillation unit or pipe still. The pipe still furnace heats the feed to a predetermined temperature, usually a temperature at which a predetermined portion of the feed will change into vapor, and that means that temperature has to be extremely high. The vapor is held under pressure in the pipe in the furnace until it discharges as a foaming stream into the fractional distillation tower. The unvaporized or liquid portion of the feed descends to the bottom of the tower to be pumped away as a bottom non-volatile product, whereas the vapors pass up the tower to be fractionated into gas oils, kerosene, and naphtha. So what you will find here is a simple diagram of the distillation process. You can see we have the supply of crude oil right here, okay, coming into this design. You can see we have crude oil coming into the column. All right, and then you can see that we have the fractionating column right here, and then you can see that we have the fractions increasing in density and boiling point going down right here, and then we can see the fractions decreasing in density and boiling point going right up. Okay, and then you can see that we have different types of products at the end of the day after the distillation processes have been carried out. You can see we have some gases at 20 degrees Celsius, and then that all those come out as liquefied petroleum gas. We have naphtha produced at the temperature of 70 degrees Celsius, and then you can see some of the chemicals that eventually come out, the usable chemicals that are, that form the end products usable for the consumers. Then we have other products that are produced at 120 degrees Celsius, and those are petrols that can be used. Those are petrols, gasoline that can be used for vehicles. Then we have other products that are produced at 170 degrees Celsius. Those are paraffin oils or kerosenes. They can be used as jet fuel or paraffin for lighting and heating purposes. We have other products that are produced at 270 degrees Celsius. Those are diesel oils, and they are used as diesel fuels for heavy transportation. We also have lubricating oil. Those are used for lubricating oils, waxes, and polishes, and so on and so forth. We have other products at 600 degrees Celsius. Those are used for fuels for ships, factories, and central heating. And then we have the residue at very, very high temperatures, which are used as bitumen for roads and roofing in general. Okay, so this is a brief example of what happens and how the products and the outputs of the distillation processes are separated, fractionated, and the final products that eventually get to the end users. So basically, you should know what these products are, and at the same time, you should know exactly what the products are eventually used for, or the various applications of these products or outputs from the distillation process. Now let's quickly talk about reforming. Reforming is a process which uses heat, pressure, and catalyst to bring about chemical reactions which upgrade naphthas into high-octane petrol and petrochemical feedstock. The catalysts usually contain what we refer to as platinum. What you see right here is what we refer to as the reforming process, the reactions that take place in the reforming process. And then we have what we refer to as cracking. Cracking processes break down heavier hydrocarbon molecules, which are high boiling point oils. They break them down into lighter products such as petrol and diesel. These processes include the following sections. We have the catalytic cracking, we have the thermal cracking, and we have the hydrocracking. So this is a catalytic cracking reaction. You can see how these all play out. Then we move on to the alkylation. Alkylation refers to the chemical bonding of these light molecules with isobutane to form larger branched chain molecules that make high octane petrol. The larger branched chain molecules are referred to as isoparaffins. So this is a reaction for alkylation. Then we have the isomerization. What is isomerization? It refers to the chemical rearrangement of straight chain hydrocarbons, which we call paraffins, so that they contain branches attached to the main chain isoparaffins. And this leads us straight to polymerization. Under pressure and temperature over an acetic catalyst, light unsaturated hydrocarbon molecules react and combine with each other to form larger hydrocarbon molecules. Such process can be used to react butanes with isobutane to obtain a high-octane olefinic petrol blending component called polymer gasoline. The butanes are referred to as olefin molecules with 4 carbon atoms, while the isobutane are branched paraffin molecules or isoparaffins with 4 carbon atoms. The next process is the hydrotreating. What is hydrotreating? Hydrotreating is one way of removing many of the contaminants from many of the intermediate or final products. In the hydrotreating process, the entering feedstock is mixed with hydrogen and heated to temperatures of 300 to 380 degrees Celsius. The oil combined with hydrogen then enters a reactor loaded with a catalyst, which promotes several reactions. Hydrogen combines with sulfur to form hydrogen sulfide. After discussing all of these processes, we then want to talk about oil and the environment. What is the impact of oil on the environment? First of all, we want to look at these three types of environment that are important to us. The first one is the air. The second environment is the water. And then the third environment is the land. What is the effect of oil on these environments? Let's take the air for an example. Preserving air quality around a refinery involves controlling the following emissions. Number 1, sulfur oxides. Number 2, hydrocarbon vapors. Number 3, smoke. And finally, smells. We have to be able to control some of these emissions. These emissions, some of them are hazardous to the environment. They are hazardous to the living organisms in this environment. So we have a responsibility to control them. We have a responsibility to collect them and ensure that they do not cause hazards to the environment and the living organisms in that environment. Then we have the water. The majority of the water discharged from the refinery has been used for cooling the various process streams. The cooling water does not actually come into contact with the process material and so has very little contamination. Rainwater falling on the refinery site must be treated before discharge to ensure no oily material washed off process equipment leaves the refinery. So, processed water actually comes in contact with the process streams and can contain significant contamination. So, a lot of control has to also come into play here. A lot of attention and control has to come into play here to avoid allowing this contamination to become hazardous. Then we have the land. The refinery safeguards the land environment by ensuring the appropriate disposal of all wastes. Within the refinery, all hydrocarbon wastes are recycled through the refinery slope system. This system consists of a network of collection pipes and a series of dewatering tanks. The covered hydrocarbon is then reprocessed through the distillation unit. So we can see that petroleum has effect on the environment. And when we say the environment, like we mentioned earlier, we're referring to the air, the water, and the land. A lot of control procedures must be in place to ensure that these environments are protected, they are secure. Okay, if the water is contaminated, that can damage the aquatic animals and human life. If the air is contaminated, certainly it will damage the human lives and living organisms in that environment. And of course, the land, this will affect agriculture, this will affect habitation, and several other things are going to be affected. So we have a responsibility to ensure that these control measures are carried out effectively and adequately to avoid negative impacts on the environment. Now it is important to talk about the petroleum products. What are the products at the end of the day that come out of the various processes that we talked about, and what did they look like? We have the aviation gasoline, we have the gas diesel oil, or if you want, you can call it the distillate fuel oil. We have the heavy fuel oil residue. We also have the kerosene, the jet fuel, LPG, motor gasoline, naphtha, petroleum coke, and the refinery gas. The LPG here refers to liquefied petroleum gas. All right, let's take it a step further. The most obvious use for petroleum is as fuel. In Canada, lots of petroleum is used as fuel for heating, for transportation, cooking, and electricity generation. And this is not only in Canada, in the world at large. As long as There are humans in those environments. Most of the activities of humans require heating, it requires transportation, cooking, and electricity generation. And that is why, that is why petroleum is used as fuel in virtually almost anywhere in the world where these activities are carried out. Petroleum-derived organic molecules are also used in an incredible number of other products that include solvents, which are used in paints, in lacquers, and printing inks and cleanings, and so on and so forth. Lubricating oils and greases are used for machinery, as you can see here. These are solvents. Okay, if you go to a supermarket, you will find different kinds of solvents that are used for different kind of things. All of these are products from petroleum and the processes that are involved. Then we have the lubricating oils and greases that are used for machinery in industries and manufacturing companies. Then we have petroleum or paraffin wax, which are used in making candies, candles, packaging matches, and polishes. We also have the petroleum jelly, which are used for our skin, which are used for Vaseline. Vaseline is used in medical products and toiletries, and also for our skin. We have the asphalt used to pave roads and airfields and to make roofing materials and floor coverings. Then we have plastics and synthetic rubber. You can see this is Vaseline. You can see we have the asphalt used for making some of these floor coverings. Then we have plastics and synthetic rubber used in packaging, casings, fabrics, bubble gum, and so on and so forth. You can see some examples here, and there are too many other advantages and products that come off petroleum. Now we'll quickly talk about plastics. Plastics are actually organic polymers, and organic polymers can be referred to as long chains of smaller carbon-based chains that have been linked together. So this is ethylene, as you can see, and then what you can see here is polyethylene, which is a macromolecule. You can see many smaller chains put together, and then you can see a condensed formula for HDPE, which means high density polyethylene. This HDPE represents the recycling symbol, and it is commonly used in household plastic items such as milk cartons and liquid laundry detergent bottles. Okay, when you look at your plastic bottles, plastic items such as the milk cartons and liquid laundry detergent bottles, and you see the sign, it means HDPE, which represents high density polyethylene, and this is the formula for that. Okay, and all of this polyethylene put together, these smaller carbon-based chains put together or linked together, is equivalent to what we do have here. Linkages of more complex units can be seen as follows. The plastics that we use are more complex than simple carbon-hydrogen units, but are linked together in the same way. Now, it is not that important to remember all the chemistry of these molecules. The important thing is to appreciate the fact that plastic molecules are made of smaller repeating structural units, as you can see here. These are repeating units. This is polyethylene terephthalate, which can be called simply as polyester. Okay, these are linked ester units called polymer. These are also linked ester units called monomer. All right, mono means single, poly means many. All right, so these are linkages of more complex units of hydrocarbon. It is important to appreciate the fact that plastic molecules are made of these smaller repeating structural units. What are the qualities of plastic that we have to pay attention to? First of all, plastics can be made lightweight or heavy. They can be very weak or very strong. They can be molded into solid pieces or extruded as fibers. They are excellent insulators. When we talk about insulators, these will come handy during the winter seasons. If they are flexible, it means they can be very weak and strong. If they can be made lightweight or heavy, weak or very strong, it means they are very flexible. As soon as they come in contact with heat or some other kinds of processes, they can be converted into other forms. Okay, they can be molded into solid pieces or extruded as fibers for several applications, which we have already talked about, and some of them we will still talk about in the course of this lecture, in the course of our lessons. Various forms range from strong and brittle to weak and elastic. They are waterproof, and when they are waterproof, it simply means they are good for protection and for other kinds of uses. Then they are relatively cheap to manufacture. And if they have several uses and applications, it simply means that it is important we understand them, study them, and appreciate them. Most significantly, plastic products can be manufactured to meet very specific needs of customers. This is because the properties of plastics can be readily modified through manipulation of chemical components. Varieties such as nylon, polyester, polyethylene, vinyl, and so on and so forth can be molded or extruded into a wide variety of forms. Some of those forms include this plastic. This is a bottle that can be used to collect and package water or other kinds of products. And then this is a suit. You can see the suit here, the wears here. This is a polyester fiber leisure suit. And there are other kinds of wears, other kinds of fabrics that they are used for during the winter, during the summer, and during various seasons of the year, and for some other kinds of functions, including fashion and so on and so forth. So plastics actually, they can be molded, they can be worked on to meet specific needs of users and consumers. It is important to understand all of these things, all of the things we have discussed. The things we have discussed in these lessons are things we see on a daily basis. They are things that apply to our individual lives and professional lives. There are things we use both at home. There are applications that are available for domestic uses at home, and of course for office uses, for industrial applications or uses, and so on and so forth. In our environment, we see how petroleum and crude oil have been very useful and applied to our daily human lives. We can therefore say that without crude oil, without petroleum, we may not have access to most of the things that we have access to today, in terms of plastic, in terms of fashion, in terms of different applications that make life interesting, that make modernization possible in today's world. So it is important to go over this lesson again and get the best out of the concepts discussed. This is where we're going to stop the lesson today. Remember to subscribe to this YouTube channel. Make sure you give this video a thumbs up if you have learned something new and if you like the video. Also, I would love to read from you. What do you think about petroleum and crude oil? What do you think about the effect of petroleum and crude oil on the environment? What do you think about these applications and uses of the products of petroleum and crude oil? See you in the next lesson. Bye.